Well, welcome everybody. It's another great Sunday morning here in Mumbai, and I have with me today Dr. Anoop Mahajan from IITM Pune. Welcome, Anoop.
Thank you, Siddharth. Thanks a lot for having me on this forum. I'm excited about this chat we're going to have.
Awesome. And Anoop is very different from some of our previous guests. He comes in from an atmospheric science background. He's actually doing a lot more climate science work than any of us are doing. But there's so many links between what we do from our Mars exploration perspective and Earth science perspective. And one thing I think that we share in common is working in an extreme environment or different kinds of extreme environments. And I think that's something we'd like to touch upon today. And also give a sense of what it is like to work as an explorer, as a scientist in these kind of rugged, harsh, terrain environments. And what does that really give us? How is that any better from sitting in an air-conditioned lab with sophisticated instruments, with a lot of your lab staff and students around you? How is it better to actually be in that cold, windy environment and work? And I think that's something we'd like to hear from Anoop. So Anoop, let's get started. Tell us a bit about yourself. Where are you from? Where did you grow up? How did you get into this?
Right. So, well, I'm from Pune. I was born in Ahmedabad in India, of course. But after that, basically grew up in Pune itself. And my education was, until my graduation was done in Pune, after which I went to the UK to finish my master's and my PhD. After which I traveled to Spain to do a postdoc over three and a half years or so. And since 2012, I've moved back to India, thankfully to Pune itself, which is quite lucky because it's my hometown and also one of the best institutions for doing atmospheric sciences is based here. So it all came together pretty well, thankfully. And in terms of my education background, I'm an atmospheric chemist and so basically what I do is study the chemistry of the atmosphere, making observations of different types of compounds and to see the kind of impacts it has on the atmosphere.
And why did you choose to study the atmosphere? What was so exciting about it for you?
Well, the initial interest was not directly related to the atmosphere, but the initial interest was on air pollution, mainly because I grew up in Pune when it was going from a nice sleepy town into this bustling metropolis, and I could already start seeing the effects that air pollution was having on our community. The levels of air pollutants was just increasing dramatically, especially in the late 90s as the economic development started. And so what I thought was maybe I should do something in this field. And so initially I started working on things like air pollution directly. And then once you start getting into a subject, you start realizing how much more complex it is than you first envisaged. And of course, to understand air pollution properly, you need to understand how the atmosphere works. And from there, once you start thinking about local effects, you start thinking about regional and then global effects. So eventually it went on to studying climate change, but from a chemical point of view, which is related to atmospheric sciences and chemistry itself.
That's so amazing. And I completely agree with you there, especially being in India. And some of us who've had the quote unquote privilege of growing up in cities which are polluted, we tend to see this first off, but then very few people actually take note of that and then, kind of make a career out of that. So it's really interesting you were able to do that. And tell me about how is it that an extreme environment, or rather I should put it, an isolated environment that is away from the city environments, how does studying the atmosphere there help you understand, a much more, I'm guessing, more complex atmosphere above our own cities, because there's all these additional amount of chemicals that are being produced. So how does it help you to go out into the different environments? And we'll talk about which environments, but how does that help to be away from the cities?
So a simple way to explain it is what most scientists term as teleconnections, right? So the world is always connected in different ways that most of us still do not understand. The parts of which we do understand very well show that even things which are happening halfway across the world can end up affecting things like weather, on the other side of the world. So understanding not just in terms of like the physical processes, but also the chemical processes which drive the physical processes in these remote environments is very crucial, because eventually those linkages help us understand what's happening in our local environment. and whether there are any other external factors which are affecting it. Maybe there are, maybe there aren't. It's not that every region definitely affects every other region, but we know for sure. For example, a very simple example is the Southern Ocean. It's so remote, right? Because there are no emissions over there. Mostly it's natural emissions, etc. But we know what happens in the Southern Ocean, for example, changes monsoon in India. These kind of teleconnections are very, very important to understand if you really want to understand what is going to change in the future. Because even though they are natural processes, those natural processes are changing. And hence going to these remote environments is very crucial because these are the least sampled environments. So unless we have the data from those environments, we'll never be able to find out these hidden connections, which could be very crucial. And in some cases, they are extremely crucial.
And what is it exactly that you're looking in these environments, and how high up above the sea level are you making your measurements?
So it really depends on the type of chemistry we are looking at. See, the reason why I focus on chemistry rather than the physics, which is basically the manifestation of climate change. So whenever we talk about climate change, we talk about temperature rises or we talk about sea level rises, etc. These are all physical manifestations. But the drivers of this is, as I like to believe, is chemistry. Chemistry drives the long-term change in weather. And that's mainly because the chemistry changes the radiation balance, which is the amount of energy that is distributed across the world. So everybody knows carbon dioxide is one of the main drivers of climate change. It's a chemical, and that changes the radiative balance. Similarly, there are other species which change the radiative balance. So what we do is whenever we go out into these remote environments, we try and study different types of chemicals which can affect the radiative balance of the atmosphere. And then depending on the chemical, we are either very close to the sea surface or the land surface, or we are much higher up. For example, if you're trying to study the changes in stratospheric ozone, then you are higher up in the atmosphere between 16 to 30 kilometers. But if you're trying to study cloud formation, then you want to focus on the lowest 2 kilometers. So it really depends on the kind of effect you're studying and the kind of effect that effect will have on your local environment.
So I've seen how you have been to all of these different environments. So walk us through some of the different aspects. So you mentioned the Antarctic Peninsula. You worked on a vessel in the southern Indian Ocean, away from most land masses, and also the Arctic. So talk us through some of your experiences as a person. What are some of the unique challenges that you've faced as a person working in these environments?
The first thing I've noticed is you need to have a very good team, and the team also you understand the type of people who are good at excelling in these environments. Mainly because you're so secluded, the reach to the other world is so little that you end up working in a bubble. And certain people really enjoy it because it's very adventurous. I mean, if you think about it, you are really exploring in these remote environments, which very few people really get the opportunity to go and visit. So from that point of view, it's super exciting because, not just going to Antarctica or the Arctic, which are the extreme poles but even high up in the mountains or going to these remote islands or being on a ship for 2 months without seeing land even once. I mean, these are really exciting opportunities if you have the right mindset. Of course, certain people do struggle with it because it's not easy. You're seeing the same faces every day. You have a routine, and the routine is not easy because you have to make observations continuously as much as possible, and you have to make the most of your time over there because remember, all of these expeditions are fairly expensive. So you want to make the most of these expeditions while you're there. So at times you're working 17, 18 hours nonstop, and then waking up again 3-4 hours later to start another observation station or so. So it is physically exhausting. Mentally, it is extremely stimulating because you're doing something that hardly anybody in the world has an opportunity to do. And of course, scientifically, getting these opportunities are great because you're really pushing the limits of our knowledge. And which is what most scientists would like to do is extend the sphere of human knowledge that we have.
And the fact that all your senses are kind of stimulated, right? You're not just sitting in front of a screen or a laptop and thinking about these things. You're actually in the natural elements doing all of this kind of work. Have there been any moments where you've questioned the fact that why is it that I'm here? I could have probably be sitting in an office doing this. At any point of time, do those thoughts come into your mind?
Oh yeah, for sure. I mean, I'll give you a very simple example. Last year we were on a ship, and we were on the ship for 2 months. And towards the end, we started running out of food, and things were pretty dire back then. And also, we had a failure on the ship engine where the ship was literally floating around for a couple of days. And one of our common friends, Rakesh Rao, who was making a film on it, he was also on that ship. And at those moments when you're completely helpless, you start wondering that maybe it's a good idea to go and sit in an office with a supercomputer and do some simple analysis. Not saying that it's an easy thing to do, but at least physically, it is so much more relaxing or so much more easier. But I have to admit that at no point have I said that I would rather be doing either lab-based work or office-based work, but that's mainly because of my personality. I know people who excel in the field and people who excel in the office also. So it really depends on the kind of person you are.
Absolutely. And so tell me about your life outside of the work. What all are you into?
Yeah, so outside of work also, I think it as I just touched upon it, it really depends on the personality you have. And as I said, I'm fairly adventurous. I'm a very outdoorsy person. So the things I do outside of work to relax myself are things like trail running. I go running up the mountains quite a lot. I go hiking quite a lot. I like to do fun things. One of the things we do is, along with a couple of friends of mine, we have set up this brewery. So, we end up making some beer, although I don't play like a very active role in that because it itself is a full-time job. But there are these small little things which keep me happy and active outside work, which I tend to do, play a little music, the normal things which even a non-scientist, as people would call them, would enjoy doing.
And through this brewery, I believe you also run this amazing science communication program called Science on Tap. So
Yes.
Tell us a bit about that initiative. How did that come about?
So this actually started during the Trump administration. So basically what happened was when Trump got into power, and indeed we are still struggling through that, is we got into this phase of lots of disinformation, lots of wrong information being out there, and lots of people having opinions about everything, but those opinions not being rightly formed by knowledge, but just backed by emotions. So what we thought was, in order to get people to think a little more scientifically and a little more rationally, they need to increase their interaction with people who are experts. But most of the times when we have these interactions, they happen in auditoriums or they happen in like such closed environments that people don't feel free enough to interact. Or most of these events are focused towards students and young people, but the people who are making the decisions are the adults. So what we thought about was trying to get science to people who are making the decisions, but doing it in a very informal way, so that people don't feel intimidated. So you don't feel that you're going to get shamed for asking a wrong question. So what we decided to do was start doing this in restaurants and bars. And what we essentially do is call a scientist over, and over a couple of beers or over a few snacks, they give a talk about their expertise, and then people are free to ask questions as and when they feel like. And one thing I found very interesting is, I know people say alcohol is the social lubricant, but it's also a very good lubricant in terms of getting discussions going. So after even a single beer, people tend to ask questions which they would otherwise be very skeptical, not just skeptical, but a little shy about asking. And so it really does increase the interaction. And it's been a pretty big hit so far, at least. And hopefully we'll keep it going in the future.
Yeah, absolutely. And are you continuing doing it even remotely right now during the pandemic?
Yeah, so we tried doing a couple of online versions. But we've stopped doing that, mainly one, because we felt that the online space is a bit saturated right now. People are tired of listening to experts talk online. And the second thing is, the real magic of Science on Tap is the interaction, the intimate nature of it. So being in a single place and being able to talk like friends, that's where the real interaction happens. So I think this format, for Science on Tap at least, is definitely an in-person format. And as soon as we have some hold over the pandemic, we'll get started again.
Absolutely. I mean, I'm looking forward to attending one of those sessions and seeing, how people interact with each other in that kind of a closed setting.
Yeah, I hope you come and give a talk on one of those rather than just attend one.
Yeah, sure, man. I'd love to be part of that as well. Um, so let's talk a little bit about Ladakh now. We have been doing work now for about 5 years, trying to explore Ladakh from a very different perspective, though. We come in from understanding Ladakh from a Mars perspective, from a space sciences side. There are very few environments on our planet which help us understand the present as well as the past conditions that existed on Mars. And of course, that's one reason why we have banded together with several scientists across the world to do that. And this year, and this has not just been a decision that we took, just in the last few months or something. There's always been a constant effort from our side to try and merge earth science and space science efforts in India. Simply because, like you mentioned, right, the connections between different regions and environments. There's also a connection between the different studies. There's so much work that's happening for perhaps a different end goal that can easily be tapped into. And there's so much of work that is already being happening in the planetary science community that perhaps could be of use to the earth sciences. And that was the exact endeavor with which we decided to merge both climate change studies and Mars studies in Ladakh. And this year is it's a start. It's kind of an introduction for the scientists to kind of meet and get together and begin this journey. And have you had any experiences in the Himalayan environments, or how do you see Ladakh or the Himalayas playing an important role in terms of our tackling climate change as we go along?
Right. So one of the things we do when we study climate change, and this is the reason why we also go to the Arctic or the Antarctic, is because the extreme environments which do not have a lot of anthropogenic input, at least not direct anthropogenic inputs, those are very good places to study any signal of climate change. Because you're not getting this big, influence of anthropogenic emissions, but what is happening globally can affect these places, right? So Ladakh is part of the Himalayas, which is known as the third pole, and it is one of those places which is at high risk because of climate change, mainly because of the glaciers, etc., are showing big signs of change over there. So from that point of view, it's an excellent place to go and study the effects of climate change, mainly because you would be able to see the signal very clearly. So from that perspective, any earth scientist would be very interested in going and making observations over there. And in fact, there have been quite a few observations, although mainly focused on the physical parameters now. So for example, there are studies saying that since 1950, the rate of change of temperature in the Himalayan region is about 0.2 degrees per decade, right? So that's pretty significant change. And the projections, at least under the RCP 8.5, which is one of the extreme projections for climate change, shows that the temperature might increase as much as 5.9 to 6 degrees in that region. And that's going to have devastating results over there, especially in terms of the hydrological cycle. In fact, Ladakh is one of the few places where we already have some hints about rainfall increasing a lot, but snowfall decreasing. So that's changing the entire hydrological cycle. And the projections are that it's just going to get worse. And that matters in terms of the agriculture, the local way of living, etc. So it's a very good place to start studying the hints of climate change much earlier than what the rest of the world would see. So from that perspective, it's a great environment to go. From the linkage of space exploration to earth sciences, now this is something I'm particularly excited about. One of the main reasons being, so one of the techniques we use is spectroscopy, which is all of us have done that during school. You look for these, I don't know if you remember these Fraunhofer lines, which we use to study the different type of chemicals that are in the sun, for example, right? That's how we know there's hydrogen and helium in the sun. So these are absorption spectroscopy techniques. And that's one of the things that we use commonly all the time for earth sciences. In fact, all the satellites depend on that kind of technique. And that's the same kind of technique that you use to find out, what does a star which is a million light years away have in it? So that kind of linkage is very much there through the methodology. And also in terms of whether these exoplanets or whether the stars are any similar to the solar system or similar to the Earth, etc. Most of these observations are going to be done through remote sensing, which is what we have become really good at least in terms of Earth observations. So that linkage is very, very much over there. And then, of course, if we do have instruments which can go in situ and make observations and all, then those to test them, Ladakh is an extremely good place, mainly because of its rarefied atmosphere. It's higher up, so it gives us slightly, not very close to Martian atmosphere, of course, but slightly closer to the Martian atmosphere than at sea level, right? So it's a very good place to go and test the instruments also. So there's lots of linkages. In terms of the chemistry also, there's a lot of linkages in terms of how the different types of chemicals come out from the soil into the atmosphere. On Mars, it's very well known how the CO2 comes out into the atmosphere from the soil itself. Those questions can be answered by studying things in Ladakh. So from that point of view, I don't see them as two distinct fields, but in fact, there's a very nice overlap if you draw like a Venn diagram of the two.
Absolutely. And look, it'll require, a significant effort from people from different disciplines to kind of tackle this problem. And that's something that we've all learned to appreciate, that there's the near surface atmosphere, there's the upper atmosphere, there's the soil chemistry. People who have been looking at the Himalayan region, their understanding of how the terrain has evolved over the last, say, 20 to 30,000 years. We've got people who've been looking at the paleoclimate records of that region. And also from the Martian perspective, because Mars was at one point a warmer, better planet, understanding how did the climate go about changing, right? There, the climate change was happening in a reverse order. And here we're seeing it happening, in an increasing order. So understanding, like you rightly pointed out, what are the signals? What are those tipping points in which the planet or the local surface environment has evolved and suddenly let go of habitable conditions? So that's, from that perspective, we are really interested in seeing the similarities, either which way you go, whether you go forward, towards global warming or in a backward order, because that's what happened on Mars. So that's where it becomes really exciting to have a intricate understanding of the workings of these small effects and how they kind of roll over into larger effects. So there's obviously going to be micro level studies where we are focusing on specific regions and understanding the local parameters there. But then there's also this global understanding, and that's where you rightly pointed out the satellite data. And we've got an amazing amount of data that has been collected by Indian, European, American satellites that can be tapped into to be able to identify several things, looking at how the glaciers have evolved over time, how has that been changing in the last 20 to 30 years. And then with your expertise in atmospheric chemistry, that helps us kind of catch on to those specific molecules or those gases and understand what is it really that we should be measuring and keeping a close track on. So that's also exciting. Now, what is it in it for a student who's probably listening into this? He's graduated either a BSc or an MSc, or it could even be somebody who's in his 11th standard or 12th standard. All of this might be seeming exciting, but also a bit overwhelming, because he might not be able to completely understand where does he fit in. And if he's coming to Ladakh to participate in this program, he's going to be there for 7 days. And the plan, what we have in mind, is that we will be giving them an introduction in 3 different themes. So the first theme is around the past, which is the origin of Earth and the formation of the Himalayan region, origin of life potentially in hot spring vents such as the ones we see in Ladakh. And the second theme is around the present, which is understanding the current scenario, appreciating what is it that the planet is going through. The climate change aspect is largely, kind of overwhelming enough to not ignore. Everybody, if we're talking about the present scenario, we cannot ignore the fact that things are changing. And then the final theme is around the future, focusing in on Mars. So just to kind of tie in my question, what is it for a student who's coming in? What would be the most important thing that you would want him to take away in that 1 week while he's up there?
So if you talk about students who are between the age of, say, 18 to 21, 22, That's usually, at least from my experience, from interaction with students and also my own personal experience when I was that age, is that you're extremely confused. You don't know exactly what you want to focus on because, as you said, it's just so overwhelming. There's so many things that you are interested in and want to do, but it's not possible to focus on everything. So it's very hard to make that choice of exactly what to do. And programs like these, they are extremely useful, especially at that age, because you end up getting hands-on training on lots of different things. So it's not just book knowledge, which is what most students end up getting, especially in India, where we don't have as many practicals as you would have in a much more selective course, which some of the universities abroad offer. So such a program is extremely useful because you would end up getting hands-on knowledge. You would end up working with experts who are doing research in that particular field. So you're not just getting bookish knowledge, but you're actually getting practical knowledge in terms of working in the field with these researchers, but also answering questions which are cutting edge right now. So that kind of helps students, especially in that age group, make a decision whether to dedicate the next 5-10 years of your life onto one particular field, or you want to choose something much more broader. So these programs can be very crucial in terms of helping the students understand what their aptitude is and what their applicability of the aptitude is, right? Because a student who's good in chemistry need not always work on organic chemistry. I'm a very good example of that. I mean, I could easily be in a lab synthesizing different chemicals, but here I'm making observations of different chemicals in remote environments, but I'm still a chemist by training. So that idea of being able to broaden your field of view, but still apply your knowledge or your expertise in a very different area is possible only through programs like these. So that's why I would definitely encourage students, especially of that age, to attend programs like these, because they will help you think about things which are different from the usual run-of-the-mill careers that are talked about.
Absolutely. Thanks a lot, Anoop. So let's jump right into some of the questions that are coming in from the listeners. So there's a first question. Do aerosols contribute to increment or decrement of atmospheric temperatures? I've seen that El Nino used to bring colder air in winters, but this winter it has warmed the air. Is this the alarming signal of climate change and global warming?
Right. So the first question first about the aerosols. So it really depends on the type of aerosols. There are lots of different types and lots of different ways in which you can segregate them. The common way to segregate them, especially if you're looking at temperature changes, are absorbing aerosols and scattering aerosols. So absorbing aerosols are things like soot particles, what we call black carbon, anything that comes out of your exhaust pipe, essentially, right? So those are absorbing aerosols, so they would increase the temperature in the local environment that they are in. Whereas if you have aerosols which are scattering, something like sulfate, sulfur-based aerosols, those are very strongly scattering aerosols. So those would end up decreasing the temperature. So it really depends on the type of aerosol itself. In terms of the climate change signal through El Nino and La Nina, we know El Nino has a huge impact, especially on the Indian atmosphere, but it is not the only one. There are other teleconnections similar to the El Nino, so they are known as the Southern Annular Mode, or you have the Indian Ocean Dipole, etc., which also contribute to temperature changes or precipitation changes in India. So it's not as simple as saying if there is an El Nino, you would get more rainfall in India. Unfortunately, it's a lot more complicated than that, and you really need to study all the different connections to be able to answer which is the main driver behind it.
Thanks. That question was from Yashraj Patil. Thanks, Yashraj, for that question. There's a question about permafrost. Can permafrost thawing be the indicator of climate change? And do the ancient virus and bacteria present in permafrost be more fatal for humans, similar to what today we are suffering from COVID-19?
Yeah.
Sounds like a plot of a movie to me.
Exactly, it does, right? Unfortunately, it could be a realistic movie. I'm not exactly an expert on microbiology, so I would refrain from answering the second question directly. But my understanding is, yes, there is I wouldn't say a fear, but there are people who are actively working on the different types of microbes which are coming out from the permafrost, because we still don't know exactly what will come out. Whether it be bacteria or viruses, we're not entirely sure about what is going to come out and the kind of impacts they have. So I wouldn't be alarmed about it, but I would definitely keep an eye on it, is a short answer to it. But definitely a microbiologist is a better person to speak to about that. In terms of the permafrost affecting climate, yes, that is a big worry. Lots of people have been actively working on it. One of the main things people are worried about is, permafrost is essentially frozen water, right? And as it thaws, it ends up becoming like a marshland. And one of the things that ends up happening in marshlands is an increase in the emissions of methane, which is a very strong greenhouse gas. So that is a big worry. There's a lot of research happening over that in terms of how much increase should we expect when all the permafrost is melted. And there are people who are making active observations, especially up in the Siberian and Arctic environment, where we are seeing large changes in permafrost. In the Ladakh environment, as far as I'm aware, there's no continuous monitoring of greenhouse gases over these permafrost regions, but it's something that definitely needs to be done.
Exactly, that's right. I was just going to add that we will definitely be monitoring the permafrost deposits in Soka region for sure. And we've already, in fact, connected with the wildlife department, who've been installing autonomous weather stations. And I think that's a discussion we need to continue with them in the next coming weeks before actually getting to Ladakh. Another question from the audience, from Hitangshi. How important is GIS to atmospheric science in terms of application? So GIS, for those of you who might not be knowing, is Geographic Information Systems.
Yeah. GIS is now becoming a very common tool in atmospheric sciences, especially in terms of studying the emissions and air pollutants, mainly because we've now got enough information from, I wouldn't say enough, but we've got better information from space in terms of identifying what the main sources are. And hence, using GIS in addition to the remote sensing information, we can really go and identify, for example, which factory is the main emitter, or which road is the one which is causing the largest amount of pollution in a certain environment. And are there any solutions that can be offered in terms of urban planning, for example? So GIS has I don't think there are too many atmospheric scientists right now who do not use this GIS-based techniques. It's become central, but it is central in addition to another technique. So, for example, as I said, remote sensing, it's useful in addition to it. The main applicability is not just in terms of understanding the sources and emissions, but also in terms of how we plan for the future, in terms of changing how the communities are located and how the planning is happening. But it's very, very crucial.
Great answers. Question from Suryendu. There's a recent observation on the tropical rainforest of Amazon that states waterlogged woods obtained by cutting the trees vigorously release greenhouse gases like NO2. Amazon now releases more greenhouse gases than reducing. As a result, what will be the potential measures to hinder climate change's adverse effects, like the thawed, permafrost, and dust storms? Anyways, he's added a couple of questions, but I think mainly is, are you familiar or aware of this?
Yeah, so it's not NO2, it's N2O. It's a greenhouse gas, nitrous oxide, and it's a very long-lived gas which absorbs radiation. And yes, its emissions have been increasing, especially in the Amazonian region. And yeah, I mean, it's not just particular to the Amazon. Any place where we see a lot of logging tends to have similar impacts, because you go from a carbon sequestering environment into an environment which is either balanced or starts emitting carbon or basically any greenhouse gas. So what you do change is the basic ecosystem, which is beneficial for the planet, to turning into something which can have adverse effects. In terms how can we reduce the impacts? It's a very complicated answer to give, but mainly it is better planning. We just need, I don't think the science is lagging behind in terms of what we need to do to reduce climate change. The problem is with the political will and also the applicability of the political will. So the solutions are there. It's just whether we are ready enough to give up our current lifestyle to apply those solutions or not is a question. There are still scientific questions as to the uncertainty of the emissions, etc., which we are trying to answer over time. But I don't think there is any doubt that preserving these forests is beneficial to humankind in the future.
You actually led me into the next question from Anurup. He asks, why are there so many people not believing in climate change? And in general, how is it, and I'll add a bit of quirk in this question, how is it in India as compared to the West in terms of climate change? Why do we have so many activists generally who deny climate change?
Yeah, so well, there are several different aspects. At least from my discussions with people, there are essentially two classes of people which stand out. One is saying that, oh, we are too small to affect the planet, and there's a higher power which will take care of everything. Hence, we don't need to worry about. So this belief that somebody else is going to solve your problems is one strong belief that people have. The second is that my life is so short. So whatever I do, how can it affect something that's going to have happen hundreds of years later? And how can you say that with certainty that the change that you are talking about is going to happen hundreds of years later? And that's mainly because of the lack of understanding of how we run our climate models and all. Now the models are very sophisticated. They're much more accurate than they used to be 20, 30 years in the past. So we have a lot more confidence in what we are saying because we can validate those models using the current observations or the past observations. So, that understanding of the science helps you better understand what climate change is happening. So this lack of belief in climate change is mainly because of two reasons. Is the lack of faith, saying that, oh, there's something else which is going to control this, or the lack of understanding of science. And of course, the third aspect is financial. When you have vested interests in a particular company, which you want to keep going because that's your source of earning, right? So these three things mainly contribute towards denial in climate change, whereas all the information we have shows that it's correct. So, there's no doubt in science that climate change is happening, but the other aspect is the human aspect, which is a lot more complicated, as you can imagine. Yeah. In terms of climate change in India, there's very little climate. Well, I wouldn't say very little, but much less than several countries in terms of denying climate change. Lots of people accept that climate change is happening, but there is very little action in terms of it, saying that, oh, I don't know what I can do for climate change. And that's where we scientists have to do better in terms of saying, what can people do? Or rather than saying individual actions, what are actions you can take to motivate the government to change the policies, because the big changes are going to happen from government policies rather than from individual actions. So in terms of getting people better educated, I think we can do a better job as scientists in terms of doing that. In terms of the impacts of climate change within India, there's plenty of things we can talk about. There's a really nice report that the Center for Climate Change Research, which is a part of the Ministry of Earth Sciences, has released recently, and it's very similar to the IPCC reports. Talks about climate change over the Indian subcontinent itself, and that details out all the different types of changes that we have been observing, either in terms of temperature or precipitation or in terms of agriculture, etc. So it's a good starting point if you really want to get into the details of the impacts we are already seeing in India.
Mm-hmm. Great answer. Next question from Abhigyan. He asks, is it possible that climate change occurring in a particularly large geographical area could be more harmful to a small part of the same area? How could it be possible on large scales, and what could be the factors related to it?
I'm not too sure I can completely understand the question. So if you're seeing large-scale climate changes, they are not going to be uniform, right? So you'll always see pockets of higher impacts and pockets of lower impacts, even across larger geographical spread. So, for example, we keep talking about the reason why people stopped focusing on the word global warming, but rather than that moved on to climate change, was this very reason, was because certain parts of the world were not seeing an increase in temperature, but actually a decrease in temperature with time. But that's all the chaotic impact of the weather system, where things are not uniform the world over, but it's a lot more complex than that. In terms of seeing impacts, yeah, there are regions which are showing massive impacts. I mean, the Arctic is a very good example where you get a really large amplification in the temperature changes in the Arctic as compared to the entire Northern Hemisphere, even though the entire Northern Hemisphere in general is showing a warming. So yeah, you do see a lot of different regional impacts, even though they might not be the same across a very, very large environment. And those are worrying mainly because, especially if they happen in high human inhabited areas, then we are talking about large changes on human population or their lifestyle.
Mm-hmm. And you mentioned about Ladakh. So, what could be the factors of climate change that we can notice in the Ladakh area, maybe from the chemistry point of view? What are some of the main things you're
So
asking?
in Ladakh, there are two main driving factors. One of them is obviously global climate change, which is happening because of carbon dioxide. So the greenhouse gases that's going to affect every single place in the world, including in Ladakh, and we are seeing that in terms of the temperature rises. And then the second one is aerosols. Ladakh is still fairly close to the Indo-Gangetic Plain, which is one of the highest emitting regions in terms of aerosols. And these aerosols end up getting transported higher up north and have regional impacts. So these are the two main drivers. In terms of the manifestations of climate change over there, two things which have become completely, well, we have observations for, as I say, are in terms of precipitations, which is, wet precipitation and snowfall. Those have changed for sure. And the second thing which has changed is terms of the total mass of the glaciers. Certain glaciers have receded quite a lot. Certain glaciers have increased a little bit. And that really is talking about how your precipitation changes is happening on a regional scale itself. But these manifestations are clear and they'll have effects in terms of water availability, in terms of agriculture. Yeah, a simple thing is in Ladakh, they used to plant a lot more of these black-eyed peas, right? And they are not being planted as much, but now they're growing tomatoes in Ladakh. I mean, that was unheard of several years ago. But this kind of change is happening, and you are seeing that in terms of the productivity of the region.
Mm-hmm. You mentioned about the Indo-Gangetic Plains being one of the largest emitters of aerosols. Why is that?
The main reason is biomass burning and crop residue burning. So we still haven't progressed as much into cleaner fuels as we should have, mainly because of the cost of clean fuels like LPG, etc. I mean, even though we had like a couple of good programs that the government started, it has gone back mainly because of the increasing costs. So what most people who do not have the financial security end up doing is they burn very poor quality fuel, which can be as simple as firewood or poor quality coal. And these have high emissions in terms of aerosols itself. And also crop residue burning. I mean, what we see in Haryana, Delhi, etc., is a very clear signal of crop residue burning. And these are very high aerosol emitting fires, and that's one of the main reasons why we see that in the IGP area. Also, mainly because of the financial situation of the region, that is one of the driving forces, unfortunately.
So when you say that, suppose there's a problem area where there is these harmful gases or effluents that are being released into the air, how, from an atmospheric perspective, how does it affect the rest of the country landmass? Is it driven by the winds that they kind of take over, or are there any other parameters that affect?
Yeah, so basically, in terms of direct impacts, yes, air pollution is one of those things which does not respect borders, right? It will travel everywhere. So depending on the lifetime of the species under consideration or the size of the aerosols or the type of aerosols, etc., they will travel around and it's going to be advected by wind. So wind is basically going to move it around. The secondary effect you have is in terms of radiation changes. So aerosols can either absorb or scatter radiation. So they change the temperature balances, which changes the winds, for example, or which changes precipitation. That changes. So aerosols also change the type of clouds you have. So, precipitation changes because of aerosol changes also occur. So it's a very complex effect, but it is not only in the place where you have the emissions because air moves around all the time.
Yeah, absolutely. So we're getting questions in, but I think we're close to the hour. For the other questions, I see you've kind of already answered it in your discussion. So let's call it a session. But Anoop, maybe perhaps I'll let you have the last word. What do you think, given this current scenario, right? Everyone is, of course, we're all going through this pandemic at the moment, but there will be pandemics that come and there will be pandemics that go. And as long as the ones who are safe and secure and healthy and have the ability to work and study and go about thinking about these larger problems, what would be your words to take away? That how do you see them focusing in on these problems, or rather the challenges that we are facing as humanity, and what are some of the things that they can do to kind of stay in touch with scientists, or even be part of these kind of, and this upcoming Earth and Space Exploration program is definitely one way, but what should be ways in which people can kind of contribute to keeping this discussion going and being part of these solutions?
Yeah. So one of the things you mentioned was keep the discussion going. That's extremely important. You need to keep these conversations going, either within your family, your friend circle, or on a larger group basis, because these are problems which are going to affect us all. Right now, we feel that climate change is something far away, but it's not. It's already happening, and we are starting to see impacts of that already. In terms of like making changes to your own personal lifestyle, there are the common ones. You try and cycle as much as you can, try and eat as much vegetarian food as you can. These are the common ones. But more and more, we're starting to realize that the big changes in climate change are going to be driven by policy. So get involved politically, get involved in activism, because these are the things which actually drive policy itself. So as much as possible, try and start talking to your local representatives, saying that you yourself are worried about it, because all local representatives, including politicians, etc., they are not disjointed from their local community, even though sometimes we get the feel they are, but they always respond to how their electorate is going to question them. So as long as you can, find out your email address of your local representative and email them saying that I'm worried about climate change in my local region. What steps are you taking to help reduce or mitigate the problems? These simple emails or simple questions, they really make the local representatives think about this, and this reflects in policies at national and global level. So that's what I would encourage every single person to do. In terms of information available, there's plenty of information available out there online. There are lots of activists, etc., which are out there. In terms of scientists, there are lots of approachable scientists, lots of reports, etc. Read through them, increase your knowledge base, try and think about what kind of impacts you can have in terms of driving policy. But in addition to making any individual sacrifices, you have to remember that you have to push policy. That's the main takeaway I would ask people to have after this conversation. And the second thing is, programs like these are really important because they give you a much more holistic idea of what's going on. So try and not get too narrowed down on one single topic too early, because things like climate change show us that everything is interconnected and you can't just isolate one single topic and address that. But you have to think about topics in relation with each other, which is where programs like these are extremely important, especially at a young age, to attend, because they really help you think about things in a much more broader manner.
Great. Anoop, we are really looking forward to working together and doing great science together, as well as interacting with students and general public members together. And there's so much we can do. People get excited about space. We want to pull them in with that attraction, but also make them understand that our own planet is very much part of space as well. It's as much to be explored as Mars has to be explored. And that's where scientists such as yourselves come in. And we look forward to having more certain discussions, and probably once we have a little more clarity as to the exact experiments we'll be doing this year in Ladakh, we can do another session where we discuss that and put that out there as well. And remotely, it will be great if we can come up with a way in which the people who are not able to travel to Ladakh can also in some way contribute, either through discussion or some ways in which they can also be a part of whatever work we're doing. At least from a documentation perspective, we'll definitely be trying to make a vlog of all the work that's happening there this year. So thanks a lot, Anoop. I think this has been a great, exciting 50-minute discussion, and we will be announcing the next live Q&A session speaker soon as well. So thanks for all of you who've spent time on this weekend listening in. And do send in your comments, and do look at our website for registrations as well. It will be in the comment section. So thank you, everybody, and have a nice weekend.
Thank you, Siddharth. Thanks a lot for having me here, and take care. Hopefully we'll see you soon.
Thanks, Anoop.